Hello, hey guys, hi. Welcome to the lab 3 of Vertex AI. And in the previous labs, we have seen deployment using the AutoML in the Vertex AI. Today, we'll be seeing model training, model creation, training, and then serving using the custom container. So, custom container allows us more control over the compute resources and also the model code. We can use NAML framework within the custom container to deploy the model to an endpoint. So in this lab, we'll be using Vertex AI to train, serve, and monitor TensorFlow model using a code in a custom container. And the objectives for this lab will be build and containerize the model training code in Vertex AI benchmark, submit a custom model training job to Vertex AI, deploy our trained model to an endpoint and use that endpoint to get predictions. And lastly, the monitoring part, that is the drift in the input data to the model. And we'll also set up the monitoring for predictions. So first of all, let's create a new project, GCP VetexAI Lab1, let's say Lab3. So, and so it will be created in some time. Meanwhile, we can also, yeah, it got selected. So first of all, let's enable the APIs that is required for this lab. This is compute engine API. So let's enable this first. We'll also enable Vertex AI API. And container registry AI API. So the main task we'll be doing today is we'll submit a training job to Vertex AI by putting our training code in the Docker container and then pushing this container to Google Container Registry. And using this approach, we can train a model built with any framework, which was not the case in AutoML. So let's head to Vertex AI and set up an workbench. Enable this API as well. So we'll create a user manage notebook first. Go to the create new, just give a name. It is just say like 3. Just make sure to check out the region which we are deploying. Yes, we are using TensorFlow 2.11 enterprise environment for this deployment, as we are training in TensorFlow model. So we do not require any GPU as of now, but you can attach as just clicking by this. Just yeah, let's create this thing. It is created now, and we'll just open the Jupyter Lab from here. So first of all, we'll just open up the terminal from here itself and set up a directory. It's so since we are working with predicting in miles per gallon of a car vehicle based on a feature set of like horsepower and engine, the weight of the vehicle also. So we'll just name the directory as mpg and just access it. Since we are using custom training, so we'll have to dockerize the training code and then send it to the GCR, which is container registry. So first of all, let's um, make the Docker file. So as we can see, it is created here, and now we can just copy paste our Docker code. So we are using TensorFlow image from GCRI or deep learning platform, and just trainer will be the training code folder, and entry point will be the Python, and it will just run the code. So now let's head here and build co- model code. But before that, let's make one storage bucket, cloud storage bucket. Let's create this storage. Just check these things. Make sure to use the same region that we created our Jupyter lab. And let's just create, confirm. So it is now created. So this will be our bucket. We'll be using this to store our model code or the results or any artifacts that we'll be getting in within this deployment. So head here and let's add the model code here. We'll be building a train.py file for model training within the trainer folder. So just making directory for as trainer and just build trainer train train.py within trainer and just head here, open the train.py file and just copy paste our model training part. So this will be the TensorFlow model. We are loading datasets from UC Irvine repository for MPG data. We'll uh, we'll have to replace the project ID here, which we can get from this. So this will be our more project ID. Just replace it here, and everything will be set. So the model will be trained here, and it will be saved to our bucket that we just created here. It will create an mpg folder within here, and it will save our model artifacts. So so this is all about model training. So now let's dockerize this code and send it to the GCR. So head it to the terminal again. So let's set up image URI first. So name, we have to give a name to the image that will be saving it in our GCR. So let's give this, and our project ID was GCP Vertex AI Lab 3 slash MPT. Let's give it name version 1. Sorry. We need to close this comma as well. So now, yeah, it is saved in the we saved our path in the name of variable image URI. So now let's build the Docker for this image. Slash t dollar image URI. So it will take some time to create a Docker image. Once it gets built, we'll try it running the Docker image locally first, and then if we are able to run it successfully, then we'll be pushing that image to the GCR to for further deployment. Let's wait till the Docker gets built. So make sure to have the same name of this bucket in the bucket you created here. So Vertex AI Lab 3 bucket. So I was facing this issue because the name, there was some mismatch in the name. So now let's go and run the image and try if it works successfully here. If it works here local successful, then we can just move ahead and train the model within the Vertex AI. So yeah, it says model is saved in the bucket. We can also verify it here. Yeah, just created an mpg folder, and within mpg folder our model is saved. So we can now use this to make predictions. So but before that, let's push this image to the GCR, that is Google Container Registry. It's just docker push and image URI. Sorry. It says artifact registry API has not been used in the project. So let's go ahead and enable that API. So let's enable this API first. Yeah, so it is now enabled. So let's go ahead and try pushing our image again to the artifact registry of GCP. So yeah, once the Docker image has been pushed to the GCR, we can just move on to the training part. So let's go ahead and just import the model. So now we have to train our model importing from GCR. So let's do that part. We'll be using node manage dataset as we have our own dataset, and we'll go ahead with custom training. So we'll train our new model named say TF TensorFlow model lab 3. We don't need to configure this options as of now. So let's continue. So since we are not using pre-built and we have made our own container, so we'll select custom container, and our image that we just uploaded to the GCR will be imported that image. So it will be under MPG. So this is the image imported. Let's just continue. We can also enable the hyperparameter tuning if we want, but let's first make sure that we deploy the model correctly and deploy it, basically make it to the endpoint. Then we can definitely come back again and do these things. So yeah, make sure to check the region and deploy to new worker pool. Just configure the compute resources as per our need and requirements. So let's select N1 standard 8 for this type, and we don't need an accelerator or GPU. So let's just continue, and let's use pre-built container for making predictions. Since we are using TensorFlow and we're using 2.11 model for this project, we don't need accelerators GPU since we are not working with large language models. So this will be the location where we have to save all the model artifacts and the outputs. So we can create this folder as part and go ahead, and we can just start training this, and it will take around 15 to 20 minutes to train the model. And once it gets trained, we can just deploy it to the endpoint easily. So let's wait until it gets trained fully. The model has now been trained, and it took around 16 minutes to get trained. So now we'll be able to see the trained model in the model registry under the deploy and use. So yeah, this is the model we just trained, TF model lab 3. And from here we can deploy this model to an endpoint like this, deploy to endpoint. And we can just create an name of the endpoint, lab3 model. Uh, since we are creating new endpoint, just click this. Region will be the same, and so yeah, just continue. Just configure the resources you want to do, how much you want to scale, how uh, how how much there will be a traffic to your model. So we'll just keep this as a by default. We'll just change the machine that is standard and 4, and just go ahead and continue, and we'll configure the model monitoring part once it gets deployed. And once we'll be able to make inferences from the deployed model, then we can configure the model monitoring. So as of now, we'll just deploy the model as it is. Let's just click this deploy, and yeah, it says that it may take a few minutes. So let's see, and we'll be able to see the deployed model here in online prediction. So yeah, it shows deploying model. So meanwhile, this model is getting deployed. We can change the some files here. Like let's just save our data set to the GCP bucket. So while doing model monitoring, would be required to give the data source as well. So since we are just loading it from UCRY dataset, we did not save this data into our bucket. So let's save this data to the GCP bucket, so that while doing model monitoring, it can just have a reference to the dataset as well. So I just wrote this code, and let's try running this. So this is the function that saves our dataset loading from here to the bucket. So make sure to give the correct name of your bucket. This is the Vertex AI Lab3 bucket. So yeah, everything looks good. Let's go ahead and run this. So yeah, it says our dataset is saved under this. Let's refresh our bucket, and yeah, it is now being saved under the dataset.csv. So we'll be using this while configuring model monitoring. And so this is now done. Let's wait until our model gets deployed. model has now been deployed successfully to the endpoint, and the status says it is active. And we can make inferences using just giving an API request to the model deployed here. So let's go ahead and give the inferences request. So this is the code through which we can make inferences. These are the feature values that we'll give to the model, and it will just give the target value or the prediction to us. So let's run this. So, but before this, we need to change the project ID and endpoint ID as it says. So let's go ahead and change the project ID first. So this will be the project ID, and location is US Central one, and endpoint would be this ID. So let's run now. So it ran, and let's make predictions. Yeah, it predicted MPG, that is miles per gallon, for some this vehicle features is 15.69 miles per gallon it will run. So this way we can make prediction request, and it depends on the request, like how we split it currently across the 100% split. So let's refresh this and see if it. Yeah, currently there is no data available, but yeah. So as we keep on making some inferences from the model, it will show here, and just give us the performance and the resource usages. Like since we made one request, it is this one. Like how much request we made and how much traffic it would be able to handle. So this is the deployed model. Now we can currently monitoring is disabled, but we can enable it and set up monitoring as well. So for that, first of all, let's just see how our data is. Data. So MPG is our target variable, and these are all our features. So it depends what drift we want to detect, like the data drift before making the predictions, that is the input data to the model, or if you want to check the drift or the concept drift, if our results are getting more deviated from the earlier results. So we can configure both of this monitoring within the Vertex AI. So let's go ahead and configure the monitoring for the model we deployed as TF model lab 3, and it is by default version. And these are for input features, like monitoring for input feature drift. So let's go ahead and add some features. Let's say horsepower. uh, it is horsepower, and it is a float data type. So we'll just change it to float here, and this can be okay. Go ahead and let's make another one. Let's say acceleration. It is also float and false, and this is required if you want to monitor the output prediction drift. So field name is mpg is our output, false. Type is float as well. Count is fine. Training we need to give a training data source as well. So since we located our data set in the cloud storage bucket, we'll just give the location of the data set CSV. Let's give dataset.csv as a path. Continue, and what do we want to monitor? Let input feature drift. Let's set threshold to 2 and 0.2. If it's greater than or less than this, it will give us an alert saying, hey, there is some drift detected or there is some skew in the data. So yeah, for numerical features, it is Jensen-Shannon metric, and for categorical, it's L infinity. So going ahead, and it will just notify us if there is a drift detected to this email. And let's set this thing up, and it will take some time to create model monitoring, but it's a one-time process. It's If it's done first time, then we'll be able to get emails whenever there is a drift detected by the Vertex AI. We can also set it up in GCP alerts, but since Vertex AI automatically does send email to us, there's no extra need to set up in GCP alerts. So let's wait until it gets created. So it now says it created model monitoring. So let's go ahead and try running this thing. Let's name it as a test. And since our data is sourced from the cloud storage, we'll have to give the location of it. And let's give data training. Yep. Let's run this, and uh, once it gets run, we'll have a more metrics for the model. It also emailed to us says, uh, yeah, model monitoring has started and will receive the alerts if any anomalies are detected. And these are the information for model and model IDs. The test we just ran to check the monitoring part is successfully run, and let's check out the results. What it shows. So it also shows infrastructure performance, and in addition to the model performance. So let's go here and check the input drift. It says that we have put a check on acceleration and horsepower in the as a input data features. So we can schedule the run if we want to. Like we can schedule it a weekly or a monthly based on our dataset changes. So this is the run that we just created. So let's check out the result. So this is what it says that if it's greater or less than the threshold based on the baseline model versus the target, then it will just trigger the email to us. And so currently we didn't change the data set, but in going forward, if the data set in the bucket changes, then the baseline versus the target might change, and we get a trigger to saying that there's some drift in the data set. So this is currently it is all fine. That we just checked the we just inserted our data now and checked the model monitoring now itself. But going forward, they might change. So this was all about this lab. We checked about the model training, serving, and monitoring within the Vertex AI, and we trained the model using the Vertex AI code. We created then Docker image, just Dockerize it basically, and we then pushed our Docker image to the GCR. Since it was we are trying to make custom training container, so we can just work with the NEML framework we want to, and just after once it gets trained, push the image to the GCR, we can just deploy it to an endpoint, make predictions. Once we are done with the pipeline, then we can also do the model monitoring part. We can set up input data features drift, output prediction task drift, and we can also schedule the run as we just saw. So this was all about the Vertex AI Lab 3.